Hi everyone, and welcome to another exciting episode on analyzing crash dumps. In the previous part, we've seen how to generate core dump files for different types of binaries, including ones with setUID and setGID flags set. We've learned how to set kernel parameters, and then we discussed about debugging. In this part, we will see how to use Lldb debugger to perform more in-depth analysis and investigate the crashes. We already have a couple of core files that we generated before. One of them was generated by the setUID binary. Notice the very restrictive permissions. We can analyze either of them. We will use the Lldb debugger discussed in other episodes, and we will pass the ---- core option. Then, the name of the binary that produced the dump. Let's define our goals and steps. We'll start by finding which threads were executing, check the stack trace, and go from there. Let's list all the threads at the moment of the crash. Only one thread and its execution stopped at main function plus offset 40. Next, let's obtain a detailed stack trace of the crash that happened on this thread. This makes sense because we only have the start function called from libdyld, the equivalent of libc for Mac OS. You remember, the source code is very short, so not much else in the main function before the crash. Next step, in general, is to analyze the assembly instructions around the point of the program crash. We can do that using the disassemble command and -frame. See here that there's an access to a memory address. The address is computed starting from the RCX register plus 0x1F40 offset. We can view registers using either the register read command to read, for example, the value of RCX, or as with other Lldb commands, we can use a shorter form, which is print RCX. We get the same value, just that one is in hex and the other one is in decimal. As a side note, it will be useful to learn how to convert them and how to switch between those two. We will use both display formats later. So in Lldb, we can define new variables and work with them later. Let's define one, for example, for the target of the memory read operation. In this case, the variable type should be unsigned long. Be careful to specify the correct type we need and the name of the variable. Its name doesn't matter that much. Its value will be the value of the RCX register plus the offset. Very useful, we can even call external functions like formatted printing functions. We do that using expr command, which evaluates expressions. Using this method, we can call familiar functions like printf or nslog. We can try to do that and watch our variables in different formats, but right now we would have a small problem because the application is not currently running. I would like to use printf function and display the hex representation of the value. The format string needs to contain the %sign and then x. For clarity, we might also want to prefix it with zeros. and we also want its type to be long. Notice that we have an error. That's because of what I just mentioned before, the application is not running. Let's set a breakpoint here and rerun the application in the debugger. The command is break and then a star followed by the address. Just ignore the warning and run the application. The execution stops at the expected breakpoint. Take a moment to look at the state of the registers. Now we can evaluate the function call expression, so let's define again a variable, rcx plus the offset. So this is the location from where the code will attempt to read memory. We could now play with different formats. For example, instead of hex, we can use decimal format. Let's see. We can specify many other options as defined in the printf format string documentation, like the number of positions we want our result to occupy. Let's say we want 16. It doesn't really matter that much. Remember something about the address. We cannot read from this address. Let's try with memory read. Notice that the memory read fails. Let's continue. We get the crash. So we know how to view the stack trace and how to debug crashes. Another useful feature to know is that Lldb supports source code debugging. We need to compile the application with the -G flag to get all the debugging symbols. Let's see what we can do with this. In this case, we don't need the core file. Another parameter we don't need. Set again a breakpoint in the main function. Or we could use the longer form of the command just to vary things a bit. Breakpoint set ---- name main. Run this and we'll see something very useful. Now Lldb will show us the source code of the application. And from here, we can actually even go step by step through it until we reach the point of the crash. To advance on one line at a time, instead of one assembly instruction at a time, we can use the step instruction. Notice now we've reached the point of the crash. We're just before it. If we do another step, we'll get the access violation error. Very important, in this case, we have access to the source code as well. Let's view the stack trace, which should provide a bit more information. It shows us exactly the code line and position where the execution failed. So it's line 5, offset 15, which is this one over here, and it also gives us different other useful bits of information. Like the values of different other parameters, like argv array, for example. That's the array from where we tried to read. Another side note, if at this point we print the rcx register using print rcx, we want to view it as hex. Let's see how to convert it. And then print it. And the correct format string. Add the correct format string. RCX. Notice it has the same value ending in FF930, exactly the same. And that's because, let's see the assembly code. In the assembly code, we are reading from RCX, that's the beginning of the array, plus 0x1f40, that's actually 8000 in hex. Let's see what it means. We can actually convert it here. Zero x 3e8 multiplied by 8, which is the size of an element of the array plus 8000. So you can see that having access and working with source code can be very useful, especially for more complicated applications. Definitely try to make use of this trick when possible. Thank you very much for watching, and don't forget to try this on your own. Please hit the subscribe button if you liked this video. Thanks! See you later!